What is Faraday's law and how does it work? Imagine a world where moving magnets can generate electricity without any wires. Sounds like magic, right? But it is actually science at work, and it all comes down to a simple yet powerful principle called Faraday's law. This law is a cornerstone of electrical engineering and helps us understand how devices like generators and transformers work. Faraday's law explains how a changing magnetic field can create an electric current in a conductor. When the magnetic flux passing through a coil of wire changes, it causes a voltage to appear across the wire. This voltage is called electromotive force, or EMF. The faster the magnetic flux changes, the greater the induced EMF. If the circuit is closed, this voltage makes current flow, turning magnetic changes into usable electrical energy. The law is mathematically expressed as the induced EMF equals negative number of turns in the coil times the rate of change of magnetic flux. The negative sign is important because it shows that the induced EMF opposes the change in magnetic flux that caused it. This is known as Lenz's law. Magnetic flux itself depends on the strength of the magnetic field, the area of the coil, and the angle between the magnetic field and the coil. Faraday's law works in two main ways. One is transformer EMF, where a changing magnetic field around a stationary conductor induces a current. The other is motional EMF, which happens when a conductor moves through a magnetic field, causing charges inside to separate and generate voltage. In real life, you see Faraday's law in action when you move a magnet near a coil or rotate a coil inside a magnetic field. These actions change the magnetic flux through the coil, inducing a voltage. This principle is used in electric generators, where rotating coils inside magnets produce electricity. Transformers use it to change voltage levels by varying magnetic flux in one coil to induce voltage in another. Inductors store energy in magnetic fields, and when the current changes, they induce an opposing EMF. Understanding how magnetic flux can be changed by moving magnets, rotating coils, or altering the coil's area helps engineers design better electrical devices. Whether it's generating power, stepping up voltage, or controlling current, Faraday's law is the key to harnessing electromagnetic induction. It allows us to predict how voltages and currents will behave when magnetic fields change, making it fundamental to many electrical systems we rely on every day.